In commercial poultry farming, architecture is a mathematical discipline. On one side, we have structures built on guesswork. On the other, precision engineering. A commercial broiler shed cannot be sized based on available property lines, leftover materials, or a builder's aesthetic preference. Every millimeter must be calculated. When space is restricted, the biological toll is immediate. Overcrowding triggers a stress response that suppresses immune systems and craters feed conversion efficiency. They consume calories but stop gaining weight. Conversely, overbuilding the footprint creates dead zones. Heating excess volume burns through energy budgets, draining profit margins before the flock ever goes to market. A successful operation relies on the biospatial equation, a strict derivation of biological needs and fluid dynamics. To see how this works in practice, we will calculate the precise dimensions, length, width, height, and internal layout for a highly efficient broiler facility. We will use a standard commercial benchmark, a flock of exactly 5,000 birds. Instead of starting with the building, we start with the animal, deriving the architecture from the biological requirements of a single chicken. Mastering the math for a 5,000 bird model provides the blueprint required to scale an operation to any size. This diagram illustrates the foundational metric of broiler production, exactly 900 square centimeters, or roughly 1 square foot, of floor space per bird. This metric provides the exact buffer needed to prevent disease transmission, while allowing enough movement to ensure maximum weight gain. Scaling the facility requires multiplying that individual footprint by our target flock of 5,000. For a deep litter system, this sets our absolute minimum functional floor area between 450 and 500 square meters. We know the total area required, but biology alone cannot dictate the shape of the building. For that, we look to the laws of physics. With an area of nearly 500 square meters, the immediate architectural question is, why not build the floor plan as a simple, cost-effective square? This cross-section shows the thermodynamic limit. A shed's width is strictly bounded by the fluid dynamics of its ventilation. In a wide structure, fresh air enters the sides, but fails to reach the center. For open-sided, naturally ventilated houses in warm climates, the width must be capped at 25 feet, or about 7.6 meters. Exceeding this width stalls the natural crossbreeze. This guarantees rapid accumulation of lethal ammonia gas and trapped heat directly in the center of the flock. If a farm invests in an environmentally controlled tunnel ventilation system, mechanical exhaust fans force high-velocity air down the length of the building. This allows the width to be safely extended to 50 feet. While a shed's length can theoretically scale infinitely with the size of the flock, the chosen ventilation technology dictates a hard mathematical ceiling on its width. Achieving higher commercial yields within these strict dimensions forces a transition from a flat, deep litter map into three-dimensional volumetric planning. This is a 3-tier H-type broiler cage. It is the high-density equipment standard. A single unit measures exactly 1,500 millimeters long by 1,000 millimeters wide. Based on the biological footprint calculated earlier, this single 3-tier unit holds exactly 90 broilers. Dividing our target flock of 5,000 by 90 means we require exactly 56 cage sets. The architectural footprint of the entire shed must be engineered to wrap precisely around these 56 sets, minimizing wasted space while allowing clear operational access. This top-down view reveals the optimal geometric arrangement for these 56 sets: 4 parallel rows, each containing 14 units connected end to end. 14 sets multiplied by 1.5 meters equals 21 meters of continuous cages. To accommodate automated feeding, drinking, and manure removal equipment, an additional 2.6 meters of operational space must be added to both the front and back of the rows. This sets the final mathematically derived length of our commercial shed at roughly 29 meters. Calculating the exact width begins with the equipment. 4 rows of 1 meter wide cages equal 4 meters of total equipment width. Between those rows, we require human and mechanical access paths, 2 feeding channels at 1.1 meters wide, and 3 bird transfer channels at 0.95 meters wide. Adding the cage widths and the channel widths together reveals the precise mathematical width of the shed, exactly 10 meters. This 29 by 10 meter footprint represents the precise intersection of the flock's biological volume and the mechanical realities of the equipment. The final step in the biospatial equation requires shifting our perspective from the flat floor plan to the vertical z-axis. The concrete foundation must sit at least 1 foot above ground level to prevent seepage and extend 1.5 feet outward to block rodent entry. From that foundation, the minimum sidewall, or eaves height, must be built to at least 2.5 meters. The 3-tier cages stand 2.95 meters tall. To accommodate them, the central roof beam must reach a minimum height of 3.75 meters. This establishes a mandatory 800 millimeter clearance gap over the top tier. It prevents heat stress and allows unobstructed airflow over the highest birds. Above that clearance gap, the roof must utilize a double slope gable design. A strict 15 to 20 degree pitch ensures rapid water runoff during heavy rainfall. Finally, the exterior architecture requires a 3.5-foot roof overhang to block rain from entering the side ventilation windows. These vertical dimensions are not aesthetic choices. They act as rigid boundaries that manage the thermal layering and atmospheric safety of the interior. This fully rendered model represents the result of our calculation, a precisely engineered, high-density facility holding 5,040 birds within a 29 by 10 by 4 meter envelope. Biological space dictates the necessary floor area. The ventilation physics mandate the maximum width, and the equipment dimensions strictly determine the required length and height. Whether utilizing a flat deep litter system or stacked 3-tier cages, adhering to these formulas is the only way to construct an optimized environment that converts square footage into maximum yield. For more professional, data-driven agricultural insights, subscribe to the Sana Livestock channel. If you are planning a commercial shed build and require personalized consultations, contact Dr. Sana.